Welcome to this overview over the changes with the Q4 2023 update. The first thing we have changed in the 2023 update is generally the behavior of loops. Not only for loops, but mostly for loops. So effectively, they are even faster now, but that's not the main point. The point is that until now, it was not recommended that you directly jump out of a loop like what you see here. Here, when the variable reaches the loop counter, reaches 2, we would jump out of the loop and then we want to jump back to the loop later. And this wouldn't have worked like this before, because if you directly have jumped out of the loop and not gone over the next, the loop would not realize that you don't come from the next, but you come from somewhere else and would have not started from you, but just continued where you have been jumping out. So in short, loops are now completely bulletproof. You can jump out in and out of a loop wherever you want, and it will just work.
And why did we do that? We did that because we got 2 new commands for loops. You may know them from other scripting languages for a long time, and that is the break and the continue command. Let's see them in action. Then you will see another thing, and that is in the editor. The yellow stripe is now exactly on the line that's been processing. So, okay, let it run. Now let's look what happened. We have here 1, 2, 3, 4, and the loop normally would have gone to 40. But we have defined if the variable from the loop is larger than 3, then we go to break. Break goes to here, and we'll end the loop, and this is just what happens. We went to 4, and the loop stopped. Now, if you look here, we never got before next with something. Why didn't we ever get it? Because here we have the other new command, continue, and continue will directly jump to the next loop iteration. That's why we never got here. So these are 2 very common, and until now a bit missing structural elements. Until now you would have placed here a GO2, and then you needed a label before the next. Now,
Let's not get too deep into the details here. It's working and there are a few more options. For instance, you can also include a line number after the pause, and it won't just skip to the next one, but instead go directly to that line number. And everything will still be completely reliable. Let's move on to the next points. Let's make a quick change in the code and take a moment to see how quickly the commands are executed in detail. As you can see, I have just added 1 line which creates a speed dump, and this is the outcome. Let's take a look at this result.
The speed dump is a useful debugging tool. On the right, you see command names, and on the left, line numbers. In the 3rd row, you see how many times a line was executed. For example, our loop was executed 4 times before jumping out at a value larger than 3. The execution counter on the left shows the number of ticks the command needed. On my computer, the Smart Package robot can execute 16 million ticks per second. This is the number of ticks used by a single command. The next command is very fast with only 10 ticks, while the 4th command is slower with 182 ticks. We use ticks because execution speed can vary depending on your CPU.
Let me just add that you will always make the dump speed command, which we have in line 22 here, at the end of the script, and place a message box after the command, because otherwise you will not be able to read the console window because it will be closed immediately. Also, see that we have measured the total time the program used, and in our case it's 0.3 seconds.
Let's try something you may have done on your Commodore 64 or Atari home computer. How many 4 next loops could your computer do in a second? Now let's see how fast the Smart PTG robot is in free run mode, about half the speed of compiled mode.
Free run mode, which is the 2 arrows button on the editor, we can do a loop from 1 to 25000 in about 1 second. And this is a very slow virtual machine here. Also, you can see we have been in this loop even faster with the next and got an average execution time of 7 ticks, and the 4 has been decreased to 78 ticks. So, if they are in the CPU cache, it's even faster.
Compiled executables run twice as fast as in-editor free run. In free run, we saw a speed of 1.2. Let's see the compiled speed now.
Really, compiled is even twice as fast as in free run, but for debugging, free run is really good.
Here you can see a real live script. This script is a script that will check if people follow my account in Twitter or not. And if they don't follow my account, I must unfollow them, because Twitter has a limitation. You can only follow 5,000 or so and so many people if they don't follow you. So I have a lot of followers, more than 3,000, and I was following 5,000 people. So between these 5,000, there have been some people who are not following back, and I had to unfollow them. Because working through 5,000 people for a human is not really acceptable, I use the pattern search, and what I'm doing here is I'm checking on the left side the following button, and on the middle the follows you text. And if this is missing, the script will automatically unfollow the people. And this is a pattern which has a very low contrast. As you can see, follows you, this is a very low contrast pattern. And at such occasions, a problem arises that you get shadow patterns. This means you have to set the color tolerance. In this case, it was on 140, I think. And in this case, you get a shadow pattern because the letters are not just 1 pixel thick, they are 3 pixels thick, for example, and then you get a shadow pattern to the right of the original pattern. And to prevent this, we have now the new min-dist parameter, and this way you can say, please give me only the results that are at least 2, 8, 10 pixels away from another result. So you will get only one result at one place, and this makes such difficult tasks much more easy.
Can I see a short practical demonstration? How you do that with the pattern search?
Let's try it together and demonstrate practically.
I have pressed the H key on the floater bar, and this starts the human eye recorder. This is the recording tool for patterns.
Next, I check the size of the pattern needed for the sample from Twitter. We want to locate follows you on the left side. I can choose 8x8 or 16x8 for this. On websites, you would typically use distance, but since this is just a picture, we don't need to. We'll just leave it and click Record Patterns. Then I select a part of the pattern and record it.
And after recording the pattern is displayed in the HE recorder. Now, the next thing is we click on the Check Pattern button to see if the recording and the parameters are correct. I'll show you an example, and then I'll also change the parameters if we don't find all the patterns.
Example, only one follows you. Others not found due to large color tolerances. Changing parameter to see results.
Oh, now you can see the effect here. With the first pattern, you can see the effect that we found a shadow pattern. And this happens because we have now increased the color tolerance so that we find all the patterns. Now we have found 2 patterns just aside of each other. It's even 3 patterns aside of each other. And this is due to the script is 3 pixels wide. So we have found 3 times the same pattern here. And this is what the new feature will filter out. We can also see it in the description down here. You can see 431, 344, 345, 346. These patterns are directly aside of each other. And we have more. We have also shadow patterns for others of the found patterns. So that's why we have the new parameter. It will filter out all these shadow patterns. But I can totally do that. Let me just insert the recorded pattern into the editor and add the new command. Okay, you have changed the script a bit. We're calling the subprogram from the pattern search, and then we have added the debug mode to 1, and we have set the main disk to 3. Now compare the result from the debug mode and what we find on the stack.
Here's the result. The debug mode showed multiple results with varying pixel hits, but the new MindDist command option filtered them down to only the relevant positions. We now have the X and Y positions we need, from 1 to 5. This is exactly what we wanted.
And now we could just pop the results from the stack and work through one after the other to check if they are following us or not. So there have been a lot of improvements using variables. First, of course, we have 2 new commands. This is very simple. You can directly define and declare a floating point number using VFP, or you can directly define and declare a 64-bit integer variable, and they will internally not be stored as a string. Like if you use the normal var command, which will store whatever you type as a string and later convert it to the number. These numbers will immediately be stored as so-called type 4 integer or type 5 variables.
Other variable commands have been improved, such as the var command shown here. Now, you can concatenate variables by leaving out the operator or adding a plus sign. This works with all the variable commands on the right side.
The if a variable string or EBS command has been updated for cases where the second operand is empty. This is what you'll see here. In this situation, you can check if the operand on the left side is empty, which means the string is empty. Then you can determine if the string is empty or not.
Important note about variables and a smart package robot. We have an empty variable because we have defined it. If we don't define the variable at all and instead make an MBX you will get $TS. This is because undefined variables are counted as normal text, and only defined variables will be resolved. This is a useful feature, not a bug.
Okay, let me give this a shot.
Please be aware of this when using the Smart Package Robot, as we do not use delimiters for strings. The variable may contain an invisible space, making the string appear non-empty.
Let me just mention that this same feature is also offered for GS and JNS.
AI often requires the use of arrays. The Smart PTG robot previously had data blocks that could be used similarly to arrays, but they were not true arrays. However, in this version, the Smart PTG robot now has one-dimensional arrays. These arrays can also be used as 3- or 4-dimensional arrays with the help of macro commands. Let me demonstrate how these arrays work and their parameters. They can be used as string, integer, or floating point arrays. Technically, they are all string arrays, but the way data is packed into them determines the type of data they hold. You can easily pack or unpack an array to a variable or file, or unpack a set to a file or variable. You can also unpack an array from a delimiter, such as a space-delimited text. The arrays are automatically allocated memory, but you can also manually allocate memory with the dim array and clear array memory commands. The string arrays can also append and have a special role with AI commands. They can be used as string, floating point, or integer commands. In short, we now have real arrays.
Let's check some other small improvements before we get to the bigger improvements. So we have a new if ping successful IP command which can be used to ping IPv4 addresses and check if they can be reached. Then we have an if online command. This is also interesting for AI. Some of the AI runs in the cloud and you need to check if you're online, otherwise the AI that's in the cloud will not work. So you have the if online command and it will tell you if you are online or not, if you can reach the internet or not, if online. You have also jump if online, jump if not online. We have new options for the hide text command, the encryption command, and we have moved the data blocks now into the variables section. We have a lot of new file commands. File generate next numbered name, just as an example. This is also important for when you work with AI. While many AI commands will automatically renumber their result files, you can also use this command to generate a unique sequential numbered file name for other files that exist, or for a template that you will give to the command. Then we have more file commands, and these file commands, they work often on...
The file commands use temporary files to ensure safety. They rename the original file to a temporary name and then rename the working file to the original name, making the changes active. This provides a complete file, even if the computer crashes. The trimming feature has been removed from some string commands, allowing the space character to be used as a limiter. More advanced find and replace commands have been added. The trim functions have been updated to trim all ACI characters from 0 to 32, as well as carriage returns and line feeds. The resolution for numeric variables has been improved, and the variable resolution for point variables has been repaired. These were minor changes. The plugin lines and DIC command have also been improved. Now let's move on to some larger improvements.
Again, this is a new topic that contains so many new commands that it may be part of an extra video just explaining these commands that are new. So we got a lot of new string commands. Generally, they're working like, I don't know, maybe you had a Commodore 64 or an Atari home computer with Simon's Basic or Basic R+ or something. You have all these string commands related in simplicity to the old days. So sometimes you may ask, oh, everyday changes, can't I have the old days back? In programming, I kept the principles from the old days for our string commands. We have emid $, right $, left $, string split. And more like this, let me just use, for example, the split string command to give you an example how it works. We do this here.
As mentioned, this quick overview will not cover all the new commands, only a few.
This new command is all about appending strings. If you just have a short string, for example, a name or something, you can ignore this command. You can just write variable and add the other variables, and they will be appended to this variable. If you have long strings, this is what we are doing here. We are using the string clone command to repeat 1000 times the text hello and put it into this variable. If you have a large string like this is 1, 2, 3, 4, 5,000 characters. And you append this 1, 2, 3, 4, 5 times to 25000 characters. It's a larger act for the computer because you must reserve the memory for each of the variables, and this takes more time. And this is where the new cat command comes into the game. To append strings to one large string that are large strings, it doesn't make sense for short strings. For large strings, this command will reserve the whole memory in one strike, and this will save most of the time that is needed in such processes. And because of this, it will be faster. So let's see, we have a testing script here.
Here are the results. The first TIB at 0.3 seconds is for generating a string with 25000 characters using the conventional method. The second, in thousandths of a second, is for using the new cat command, which is much faster.
Structural shortcoming. You may know this command from other languages. It's called EIF. This means you give it a number. In our case here, it's a number 2. And from this number, it will select which of these variables that you give here at the end will be returned. The command allows up to 25 choices to be specified, and depending on the number that you specify here, you will get in the result variable the choice that you have selected by this number. The command allows up to 25 choices to be specified, and depending on the number that you specify here, you will get in the result variable the choice that you have selected by this number. You could have done it, of course, also with the select case option that we already have, but of course a select case option with 25 options is much larger and uses much more code than if you can do it in a simple line with one command. And of course, this is also a lot faster. And that's why we have it. Here's the new EIF. We have two choices. We have the EIF for strings. This is dedicated for strings. It will always generate a string result. And then we have the variable EEF.
Originally, I have planned to also show you the new AI feature in this video, but we are already at 27 minutes, nearly to half an hour, so we will have to make a second video with just the AI features. At least most of the other things that are new in this update are now contained. And let me show you two of the scripts that are used during this video production with the Smart Package Robot. One script, that's the commenter script, you see here. I press stop, and now what happens is the script will now take what I have said.
I'll show you the new AI feature in this video, but we're already at 27 minutes, almost a half an hour, so we'll have to make a second video with just the AI features. At least most of the other things that are new in this update are now included, and let me show you two of the scripts that are used during this video production with the Smart Package Robot. One script, that's the commentator script you see here.
So next I'm going to show you another real life application that I have done in the last days is my Twitter bar. The point about Twitter, forget in this case Twitter, this can be a help desk application, this can be another professional application for a lawyer, whatever. The clue about it is that with the Smart Package Robot you can make this bar here. And when you have this bar, you can start dictating the text directly to this application. Let's take this for example and make a small text. So I press dictate, then I get the recording window. And I press stop. And when I get the beep, it means he has recorded what I say and I can insert it. Of course, this is not what I want to say, so let me try it again. Auch an Halloween solltest du nicht so furchtbare Bilder posten. And then I have the text, so it would look like this, but I want it as a rhyme, so I press on rhyme. I wait a moment and I have the result, and then I get a rhyme and I also get automatically all hashtags that I want. Reply. So yeah, it's always funny. Not always. Okay, now I'm showing you another button. I'm now marking the text and I make copy. And This time I will ask the AI to make the complete command for me. I will just press command. In the future I may make a button negative command and positive command. But now we have, I think, only positive commands. And it will also rhyme also. And I just need to press go. And in case I don't want what the computer did, I can also press the back button and it will give me the original copied command back. So, what else do we have? ChatGPT, cheat sheet. Nice work, thank you. Now I want to rework this. And here he has translated it in German. I didn't think about that. Okay, so this is just an example. The point about this is, for example, if I go here, and this is some sort of spam, so I can say, okay, no problem, just give me your address and your phone number, and then we see further. I press stop, and in this case I insert it immediately and I get it. So no need to type something, and this is so great. That's why I wanted to show you this at the end of this video.